Now we'll see different parameters of magnetic fields. First one, magnetic field induction represented with P. Already we discussed what is the magnetic field induction. Force experienced by unit north pole, that is F by M. Of course, B is a vector quantity. Suppose if you take a field in a medium, that is magnetic field induction in a medium, Bm is equal to mu r into B naught. What is mu r? Relative permeability of relative permeability of the medium. B naught is a magnetic field induction in the free space or vacuum or air. This is in any medium here. So relation. And other quantity, intensity of a magnetizing field or magnetizing force, that represented with H. And what is H means? So H is a ratio of magnetic field induction in that medium by permeability of that medium. Suppose if it is a free space, B naught by mu naught in a medium means Bm by magnetic field induction in that medium by permeability of that medium. So this is constant. It is not depend upon any medium. Suppose if you are applying H field in vacuum, even if you are introducing some body there, suppose you can take here is some field H is there. Flex lines I draw here. Field is magnetizing field. Magnetizing field is or magnetizing force is H is there. And in vacuum H is there. Suppose if you are introducing iron bar or a ferromagnetic substance, here it is going, B is going to increase. Bm is equal to mu r into B naught. Already we have this equation here. You see, Bm is equal to mu r into B naught. B is changing, but H is same only. H is not changing. H remains constant. Even if you are introducing medium or remove the medium, field of magnetizing force remains constant. What is intensity of magnetizing field or magnetizing force? It is a ratio of magnetic field in that medium to magnetic permeability of the medium, which is independent of the medium. It is not dependent upon the medium. What are the units? Actually, it is a B by mu naught. That is Tesla by units of mu naught. You have to take that. We get units of H is ampere per meter, and CGS. This is SI units. These are SI units. CGS units are Oersted, scientist name, and dimensions ampere per meter. That's why A L minus 1 you can write. That is a dimension. And suppose you can take B magnetic field induction in free space is mu naught H from this relation. In a medium means what you can write? B medium is equal to mu H using this. And what is mu value? Mu is equal to mu r into mu naught. Mu r is relative permeability. What is mu r? It is a ratio of permeability of medium to permeability of free space. From that you can write mu is mu r into mu naught H. So what is mu naught H? Mu naught H is B naught only. So we can write Bm is equal to mu r into B naught. That only what we write here. So we can write field induction in terms of H or in terms of B naught also we can write. Another quantity, intensity of magnetization, represented with I. Here already we discussed. Suppose here field strength is H is there. If you are introducing a ferromagnetic substance, what happen? B increases, but H is not increases. Why B increases means because of intensity of magnetization is present there. Medium present means it create I value in the field. So here you see, if this is the H value, initially there is no medium, you can take air or free space or vacuum. And now if you are placing a material here, it can induce other field in the direction of the field. That what you call induced field is I. So in addition to H value, I also added. That I what you call intensity of magnetization. See that names of these magnetic field induction, magnetizing field or magnetizing force. I is intensity of magnetization. Intensity of magnetization. What is the definition of intensity of magnetization? It is a magnetic moment per unit volume. So what is magnetic moment? Capital M by volume of the magnet V. Magnetic moment, you can write total length of the magnet is 2L into pole strength by volume also. What is length of the magnet? 2L into area of cross section. A is here area of cross section. 2L get cancelled, M by A. So intensity of magnetization we can define, that is magnetic moment for unit volume or pole strength for unit area. So pole strength ampere meter and area is meter square. So what you get? Units, SI units are ampere per meter. Ampere per meter you get. And units of I and H both are same only. What is H means? Applied field. What we apply from externally. What is I? How much field induced in the medium. So both quantities are same only. One is directly what we are applying. Other one what it induced in the material. That is I, intensity of magnetization. And units and dimensions both are same as H. Other quantity called magnetic susceptibility. And susceptibility, they use a symbol like this. This they call psi. Symbol name psi. Magnetic susceptibility. What is magnetic susceptibility means? The ratio of magnitude of intensity of magnetization. That is nothing but I to the magnetic field strength or magnetic field. Magnetizing field. So susceptibility we can write as I by H. So we can say simply how many times the induced field is when compared to applied field. What is I? Induced field. H is applied field. What is susceptibility? It is a ratio of induced field to applied field. You can write. And both have same units. That's why there is no units for susceptibility or psi. No units and no dimensions. It is a ratio of intensity of magnetization to magnetizing force or magnetizing field. That is psi is equal to I by H we can take. Now we'll see a relation between this susceptibility psi and relative permeability. Mu R. Relative permeability is mu R. So we know what is relative permeability. So here we discuss mu is equal to mu R into mu naught. And here susceptibility formula psi is equal to I by H. And use the concept here B is equal to mu H, and that is equal to mu R mu naught H, that is equal to mu relative into B naught we can write. That equation I am going to use here, that is B is equal to mu H, which is equal to mu R mu naught into H. That you can take it as equation number 1. And second equation, if you take any space, there they apply a field H from externally. If they are introducing here some material, inside material also some magnetic field is induced. That induced field what we call I. So what is generally B value? B is equal to mu naught H. If free space is there means. Suppose if you are introducing a medium, then what you can write? Mu naught into H plus I. Both are there. One is applied field, other is induced field. B is equal to mu naught H plus I. So here you can take I we can write as, you see H take common outside, and 1 plus I by H we can write. What is I by H? That is nothing but psi only, susceptibility of the medium. So that you can write mu naught H into 1 plus susceptibility, equation number 2. From equation 1 and 2, you can compare these two. Mu naught H, here also mu naught H is there. Then what you get? Mu R is equal to 1 plus psi. Nothing but relative permeability of the medium is equal to 1 plus susceptibility we can write. Relative permeability is equal to 1 plus susceptibility. Here what we discuss first, that is magnetic field induction B, and after that intensity of magnetizing field or magnetizing force H, intensity of magnetization I, here susceptibility, and then relation between relative permeability and susceptibility.